All right, so the idea here is we're going to solve system equations or inequalities, so they could be either one of these by graphing, okay? Basically, we're going to try to find where they cross. Where they cross. That's the idea is. Now, when we get to equations, they might cross in a single point, or they might have a parabola and a line, and they might have two places where they cross. Well, inequalities are going to be a little bit different. Inequalities are going to have like uh, two shaded regions, like you might have this shaded region and this shaded region, and then the overall answer to the question would only be this section over here. And so you're going to literally see basically me graphing one whole section of a graph where the two cross over or overlap. So in terms of actual equations, the set of values, a set of values for the variables that make all the equations true. So in other words, you can plug the points in and you get what we call true statements. So we'll take a look at that here in a second. So how would we graph this one? Well, the first one has a y-intercept at -1. So I know that it's going to cross through at -1. It's also got a slope of -1. And we remember that that means the same thing as down 1, right 1. So down 1, right 1, and down 1, right 1, and down 1, right 1, and so forth. And so we can get the idea of what the picture looks like. I'm going to use the actual line graphing tool so that I can make a nice looking line, as good as I can possibly make it through all these points. Okay, so there's my one line. And let's pick a different color for the other one. So this one has a y-intercept of -7. Okay, so that's down here. Let me use the dot tool. Come down here to -7 and put a dot on the graph. I know it's a real small red dot, but hopefully you get the picture. Now, the slope of that is, let's see if I can do that again. The slope of that is -2, -2. So that means down to right 1. Now, I always encourage my students to use the right first. But if I go down 2 and right 1, it literally puts me off the graph. But I will say that doing that allows me to get the idea of which way it has to go. So it has to go like this. So if I'm going the opposite way, I can go up 2 and back 1 and up 2 and back 1. And so now I have the basic idea of the line, and I can come up and use the line tool and graph more of the points. So let's see if I can get a hold of this. Go through here, keep it going, and find out where the two lines cross. It does look as though we have a winner right there at -6, +5. -6, +5. That is the intersection and the answer to the question. Now, what did I mean by it makes the statements true? Well, in a future question, I'm going to show you that you can plug those in. But if I just quickly showed you that 5 equals the opposite of -6 minus 1. 5 equals -2 times the opposite of 6 minus 7. What you're going to see, so I basically took the coordinates and I plugged them into these two equations. And what you'll see is you get 5 on both sides, no matter which way you do it, right? 12 minus 7 is 5. Oops, that's a bad looking 12. Oops, why is it doing that? Scribble 12. Well, let me write. Why does it continue to zoom in and out? I don't get it. What is going on here? Why can't I just write 12 minus 7? That's 5. And then down here you have 6 minus 1. 6 minus 1. That's also 5. So the algebra shows me that it works. So does the graph. Okay, so I go to the next one. We have our dot at, we'll have a dot here at positive 7. Whoops. Let's try a little bit bigger font for that. At positive 7. And the slope is negative 2/3. So down 2, over 3, down 2, right 3. So you've got the basic idea right there of the line. We can graph the actual line. Something like this. Okay. And then we can find different color. 1/2 x. So the y-intercept looks like it's missing, but we know that that means it is 0, right? So y-intercept looks like it's missing, but it's a 0. We know the slope is 1, so then 1/2, I should say, so that's up 1 over 2. Up 1 over 2. Just following the pattern until, hey, look, it looks like the line runs into it. So we know the answer here is the coordinate 6, 3. Next slide, I think. Yep. So the system, we want to solve this. The first equation has been graphed for you, so I need the second equation, 2x plus 1. So once again, we use the strategy of our y-intercept being at positive 1, but this time we have a slope of 2, right? So keep in mind that's 2 over 1. So up 2, right 1. Up 2, right 1. Up 2, right 1. You're going to see that this thing is going to cross multiple spots, not just one spot. So we're drawing our line. And it's crossing at 2 spots. So we know that we have a solution here and a solution here. Both of them must be the answers to my questions. So 1, 3, and 5, 11. I can come over to the next example and do the same thing. They drew the first one for me, so I need to draw the second one. And let's see here, y-intercept at 1. The slope, slope equals 1. Slope equals 1, and just to remind you, a slope of 1 is 1 over 1, so that would be up 1, right 1, up 1, right 1, up 1, right 1. That gets me my line. And we can see there's 2 answers to the question also. We got one answer here and one answer here. So that is the point. 3, 4. 3, 4. And also -4, -3. All right, solve the systems by graphing. Now, I think for a little bit of, to make this a little bit easier on yourself, we should solve for y. So there are other ways to graph lines, but I think it's easier for a lot of you if you just solve that for y. So that second equation would be y equals negative 2x, because the 2x would have to come to the other side, plus 5. And then the other one is already solved for y, and so we can find, we come up 5 and plot our first dot. And the slope is negative 2 over 1. As a reminder, negative 2 over 1 would be down 2, right 1. Down 2, right 1. So down 2, right 1, down 2, right 1, and so forth. So the other one is, the original one had a negative 1 for the y-intercept, and it was also negative 2. So that'd be down 2, right 1, down 2, right 1. So what happens when you have the same slope? Same slope. Why, yes, parallel lines. And how many times do parallel lines cross? Never cross. No solution. That's the situation you're in. So when you see a system that has parallel lines, but that means that the two lines will never cross. Okay, so second equation, we're going to solve that for y, so that the 2x moves to the other side, so that would be negative 6y equals positive 2x minus 18. And then we're going to divide by negative 6, divide by negative 6, divide by negative 6. And we get the second equation is y equals negative 1/3 x plus 3. Oh my goodness, what do we have here? The exact same equation. Same equation means the lines sit on top of each other, so they cross at every point. There are an infinite number of solutions. So we say things like infinitely many solutions. And we can abbreviate that IMS. Now, if you want to get all cool and use the infinity symbol, I would be okay with that. Looks like a sideways 8. Hold on a second. Now, I still want you to graph it. So you're still going to put a dot at 3. The slope is negative 1/3, so that's down 1, right 3, down 1, right 3. And of course, if you want to do anything, go in the opposite direction. You just reverse that, and you can plot your line. So something like this would be fantastic. You know, you can always put arrows on the end, because that's true. I haven't been doing that. Maybe I should have done that, gone back and added the arrows to my different pictures, because technically that is true. Okay, so this is just going back to the algebra stuff. They're asking me if 4,2 is a solution to the system, so they've chosen a random point. So I'm going to check it by plugging it in. 4 plus 2 times 2 equals 8. And that is a good answer because this side of the equation does equal 8, so that's 8 equals 8. That checks out, okay? Go to the next one. I got 2 times 4 minus 2 equals 6. That would be 8 minus 2 equals 6. That's 6 equals 6. That is a good solution. So yes, it is a solution. So that's the algebra stuff that you can do. So not too complicated. You're just plugging it in to see if it gives you the same result. All right, let's go to the next one. So now we've got a couple different things. Might I remind you that this is a horizontal line? All equations that are like this and all x equals are vertical lines. You've got to get that in your mind. I know, it sounds different because we call them the x-axis and the y-axis, but their equations are actually x equals and y equals. So y equals 3, the horizontal line is going to do this, and then the x equals negative 3 is going to do this. So where do they come together? Well, obviously the answer is negative 3 comma positive 3. It's almost like they told you the answer. That's right. It is exactly like that. Well, what happens when you come to the next one? These are both vertical lines, right? Hold on a second. Okay, so x equals 0, vertical line, right down the middle. And x equals 5. Another vertical line over here at 5. So we got our two vertical lines. Oh, they're parallel. No solution. That over. Because nothing crosses. More practice. First one, x equals negative 2. Vertical line. Second one, not a vertical, horizontal. Remember, you got to go to the y-intercept is at 4. The slope is up 5 over 2. So that's up 5. That takes me off the graph and over 2. So that's about right there. Which also can be used the opposite direction. Down 5, back 2. And so now we can draw that line. And it looks like the solution is at a negative 2, negative 1. Element over here. Put another vertical line on it. Y, or no, horizontal line this time. Y equals negative 6. So, wait a second. Those don't cross at all. No solution. And I think this wraps up our video. I don't think there's anything more we need to add to this. You're just looking for places where things cross. And sometimes they do, sometimes they don't. See you in class.